Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading are helping you out. Okay, this is the second video guys of me answering the question the 2023 physical science paper 1 question paper. Please note that there is a first video that I've uploaded whereby I'm tackling question 1. Yeah, okay, let's just get right into it. We are told that two blocks A of mass 4 kg and B of mass 9 kg are connected by a light inextensible string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. Okay, and then now a constant force F acting parallel to the plane is applied to block B, as shown in the diagram below. The blocks now accelerate up the incline at 2 meters per second upwards. Okay. The first question says state Newton's second law of motion in words. It states that when a net force acts on a body, the body will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the body. Others may prefer to say that F net is equal to the rate of change of momentum. It's still okay. It's still okay. Okay. And then we are now told that the kinetic frictional force acting on block A and B, excuse me, are 5.88 newtons and 13.23 newtons respectively. Draw a labeled free body diagram showing all the forces acting on A. The forces acting on A. Okay. I will draw two different free body diagrams. Firstly, I have a tension which pulls the block A up the incline, and then I have the normal force which is always perpendicular to the surface, and then I have friction Fk there, and then I'll also have Fg parallel. Since I'm choosing to show Fg parallel, I must also show Fg perpendicular. Fg perpendicular. Are you together? But please, guys, whenever you write, do not write T. Right? You must write in full: tension, F normal, F friction, gravity parallel, gravity perpendicular. Just do that, guys. Now, excuse me. Others would prefer to draw the free body diagram like this. I'll simply have my free body here. I'll have tension, F normal, and then I have friction, and then I'll have weight here. Please remember that weight is acting vertically downwards. Né? Always remember that. You can either draw it like this or draw it like this. You'll get your 4 marks, guys, in full. I prefer drawing it like this because I will use all the forces, especially if my object is moving on an inclined surface. I prefer to draw it like this. Okay, now we are being asked to calculate the magnitude of the tension in the string. The resultant force is equal to mass times acceleration, right? In this case, we have tension going up the incline, and then we have two opposing forces going down the incline, right? So in this case, we have tension plus the negative frictional force plus a negative Fg parallel, they are all equal to MA. Why are they negative? Because they are opposing the direction of motion. Are you together? They want me to find the tension, right? Tension plus negative 5.88 plus negative FG parallel. I'll get it by saying mg sine theta, right? The mass is 4 multiplied by 9.8 multiplied by sine 35 is equal to 4 multiplied by 2. And then I'll find my tension to be equal to it's 4 times 2 plus 5.88 4 times 2 plus 5.88 plus 4 multiplied by 9.8 multiplied by sine 35. I'll simply get 36.36 newtons. That will be the magnitude of tension, of the tension in the string. Tension is 36.36 newtons. Okay, and then now they want us to find force F. Force F is applied on block B. So that means we must draw the free body diagram for block B and then calculate the force F. May I please erase? Okay, it's fine. The free body diagram for block B, I'll have force F being applied there. Then I'll have frictional force Fk going down the incline, and then I'll have Fg parallel also going down the incline. I also have the tension also going down the incline, right? Then I'll have the F normal and Fg perpendicular. Alright, together. So for me to calculate force F, I simply need to say F net is equal to MA. I have force F plus the negative frictional force because it's acting on the opposite direction, plus the negative Fg parallel plus a negative tension. They are all equal to MA. They are all equal to what? MA. Then all I need to do, guys, is to just substitute. I still have F plus a negative frictional force. My negative frictional force for on block B is negative 13.23, right? Plus negative Fg parallel 9 times 9. I'll have negative 9 multiplied by 9.8 sine 35. I don't have space here, guys. Let me just do this. Let me find the Fg parallel down there, and then I'll just substitute. Fg parallel is mg sine theta, right? The mass is 9, g is 9.8, and then I have sine 35 degrees. So 9 times 9.8 times sine 35 degrees, I'll get 50.59 newtons. Okay, so now whenever I work, I'll simply have F here minus frictional force is 13.23. Fg parallel is negative 50.59. 36.59. Then my tension is 36.36. This is still equal to MA. Ne? Remember that MA is 9 multiplied by 2, which is just 18. So whenever I substitute there, I'll end up having F to be equal to 9 times 2 plus 13.23 plus 50.59 plus 36.36. So force F is equal to 118.18 newtons. Force F is equal to 118.18 newtons. Okay, now we are being told that the angle that the plane makes with the horizontal is now decreased. How will this change the frictional force acting on block A? Whenever you decrease the angle, you are always increasing frictional force. How so? Please note that the decrease of an increase or a decrease of an angle will always affect the components of the gravitational force. Ne? I know that my gravitational force, which is weight, is equal to mg sine theta plus mg cos theta. Are we together? So these two will give me the weight. Are we together? And whenever I decrease my angle, let's say I have a triangle over here, ne? I have an angle there. When I choose to decrease my angle, I'm simply decreasing the height, the height above the ground, ne? And whenever I decrease the height above the ground, remember that according to soccer tour, that means I will be decreasing FG parallel. Are we together? And then whenever I decrease FG parallel, I will simply increase the FG perpendicular. Are we together? But what do I know? I know that FG perpendicular is equal to the normal force. If I increase FG perpendicular, that means I'm also increasing the normal force. But remember that I have an equation that says friction is equal to mu k multiplied by normal force. Whenever I increase the normal force, the frictional force will also be increased. Are you together? So the answer here is increase. Explain your answer. You'll simply say that whenever an angle is decreased, you are increasing the FG perpendicular. Are you together? And remember that FG perpendicular is equal to the normal force. If FG perpendicular is increased, therefore the normal force is also increased. Are you together? But remember that the frictional force is directly proportional to the normal force. If I increase the normal force, friction will also increase. Yeah, that's how the change in an angle affects the frictional force. Are you together? If an angle is decreased, frictional force will be increased. If an angle is increased, frictional force will be decreased. It ends there. I hope, guys, the video was helpful. Please stay tuned and wait for more.